In the fading warmth of summer 1977, two spacecraft lifted off from Earth on a mission unlike any before. NASA's Voyager 1 and Voyager 2 weren't just machines built to explore. They were the embodiment of human ambition and curiosity. These twin robotic emissaries were sent not only to study the planets of our solar system, but to journey beyond them into the vast, uncharted interstellar space. They carried with them more than scientific instruments. They bore the dreams of an entire civilization, daring to touch the edge of the possible. Though their onboard computers were primitive compared to today's smartphones, the Voyagers represented the peak of late 20th century engineering. Crafted to endure the deep space environment, bombarded by radiation, tugged by gravity, surrounded by silence, they were built to last far beyond their intended 5-year lifespan. From launch, Voyager 2 followed a precise course using the gravitational pull of giant planets as slingshots to speed along its journey, a celestial dance choreographed by human minds decades in advance. As Voyager 2 drew closer to Jupiter, it began capturing unprecedented images of the planet's roiling atmosphere. It revealed the Great Red Spot in greater detail than ever before, a storm so massive it could swallow Earth whole. The spacecraft observed turbulent cloud formations, uncovered new moons, and studied a thin, ghostly ring system that had eluded detection from our telescopes on Earth. But this was only the beginning. In 1981, Voyager 2 arrived at Saturn, where its camera caught the sunlight glinting off the planet's iconic rings. Unlike the flat static bands scientists once imagined, the rings turned out to be rich with structure, twisting braids, density waves, and icy particles dancing under the influence of Saturn's many moons. With guidance from Voyager 1's earlier flyby, Voyager 2 was able to capture Saturn in its full glory, revealing a world more dynamic and mysterious than anyone had expected. Then, in 1986, Voyager 2 did something no spacecraft had ever done. It visited Uranus. Wrapped in a hazy blue-green atmosphere, this ice giant rotates sideways, as if it had been knocked over by a cosmic punch. Temperatures there plummeted to minus 353 degrees Fahrenheit. The spacecraft detected 2 faint rings and identified 11 previously unknown moons. Even more intriguing was a giant magnetic bubble Voyager 2 passed through, evidence that Uranus's magnetic field behaved in unexpected ways due to the planet's extreme tilt. 3 years later, in the summer of 1989, Voyager 2 reached the last of the solar system's giant planets, Neptune. No spacecraft had ever been there before, and what it found was astonishing. Deep blue and windswept, Neptune raged with the fastest storms in the solar system. Winds screamed across its clouds at over 1,200 miles per hour. Voyager 2 discovered another massive storm system, the Great Dark Spot, and sent back the first images of Neptune's faint rings. But the real showstopper was Triton, Neptune's largest moon. The probe captured eerie footage of nitrogen geysers erupting from below its frozen surface, clues that even this distant, frigid world might hide an underground ocean, and with it, the potential for life. As Voyager 2 ventured farther from the sun, the light grew dimmer, but the spacecraft never stopped transmitting. In 2018, more than 4 decades after launch, it crossed the heliopause, the invisible boundary where the solar wind yields to the interstellar medium. It followed Voyager 1, which had made the crossing 6 years earlier. Suddenly, we were no longer just a solar species. We had reached the space between the stars. There, Voyager 2 detected a faint, persistent hum, the sound of plasma vibrating between distant suns. For the first time, humanity could measure the density of that mysterious space. Though Voyager 2 now drifts more than 14 billion miles from Earth, it still sends data home, each message taking more than 18 hours to arrive, even at light speed. The signals are weak, buried in cosmic noise, but every bit of information is precious. With each passing year, as its power source slowly decays, mission engineers are forced to make painful choices, shutting down one system to keep another alive just a little longer. Today, the spacecraft draws less power than a light bulb in your living room, yet it continues to function, defying the odds, carrying out its duty in the cold silence of space. The images Voyager 2 sent back in its prime are haunting in their beauty. Glimpses of starlight on Neptune's moons, the dim glow of Saturn's rings, and the shadowy blue orb of Uranus, all etched onto film and into memory. These aren't just photos of faraway worlds. They're reflections of who we are and what we strive to understand. They speak to our smallness, yes, but also to our boldness, our capacity to dream. And attached to Voyager 2's side is perhaps its most human element, the golden record. Engraved with greetings in dozens of languages, the sounds of nature, music from Bach to Chuck Berry and a mother's heartbeat. It's a time capsule of Earth, a message cast into the galactic sea. It may never be found, but that isn't the point. It exists. It sails on, unchanged and eternal, carrying the essence of who we were at the moment we first reached for the stars. Voyager 2 has now traveled farther than any spacecraft still capable of communicating with us. Its journey has outlasted presidents, wars, and generations. And though its voice grows fainter, its legacy rings loud. It taught us to explore, to ask questions, and to see the Earth not as the center of the universe, but as one precious dot in a sea of wonders. Long after the last signal fades, Voyager 2 will continue its silent drift between the stars, a ghostly ambassador of a civilization that once dared to dream big. In its voyage, we find not just science, but soul. And through its eyes, we learned not only about distant planets, but about ourselves.